So today I'm just gonna share experience we had as Bosch working with global manufacturing customers. So the slide talks about what is our team into, what kind of skill sets you will find in our team. You would also see a couple of slides talking about the different maturity models in data analytics. What is the difference between data analytics and AI. We also have a couple of slides, to give you a flavor of what kind of use cases we solve for the industry. So without any time delay, we'll get started. So, okay, so I'm part of Robert Bosch Big Data and Analytics team. So the team was created back in 2012 as a data mining team. It was one of the new topics. So we quickly, had COE formed, and we had the best minds brought into work in the COE. And currently, the COE consists of over 50 plus data scientists, big data engineers who are able to scale the data science projects on cloud or on premise. When I say cloud, it can be Azure. We have capability to work on Google or AWS. We have people with advanced visualization skills. It can be Power BI, Tableau, so on and so forth. So the mission statement we have is high impact business use case is where we work, and we focus on improving both the top line and bottom line across multiple domains. The reason we say domains is because Bosch has multiple domains where it has automotive manufacturing plants. We have consumer electronic manufacturing plants. We have silicon chip manufacturing plants. We have advanced electronics manufacturing plants. So, we are also, venturing into healthcare devices. So we do support Bosch across different domains. Okay. So the value, what my team would bring to Bosch and global customers is to extract value from the data you've already collated, or, extract value from the data coming, from your devices or smart products in field. And when I say value, it can be value in terms of predicting the future events and alerting if there is any deviation, or it can even be root cause analysis or extracting useful information from historical data. Any questions? Okay. So this slide talks about different uh, use cases. We uh, usually see industries, take as a step-by-step approach, right? See, when you have a new data analytics team, usually, we see people working a lot on descriptive and diagnostic use cases where you have historical data, and the use cases are more on generating reports like OE reports or trying to find a root cause. So these use cases are predominantly worked upon by putting data together and generating some graphs, or using tools like Tableau, Power BI, or business objects to extract reports. Okay. So then, we have seen as and when companies mature, they try, venturing into predictive. So predictive use cases are where, you make use of your historical data to predict future events. The best example can be demand forecasting, right? You have historical data of last 3 years sales, and making use of that historical data, you identify the trends, patterns, and then you try to predict what would be the most likely, sale demand in the market for your product. Okay. And when you have companies experienced with a couple of predictive use cases, the next step in the journey is to go for a prescriptive use case, where you predict an event. And for say, if you predict two events, then you try to map the two events into what should be done if the event A occurs, what should be done if the event B occurs. Say, for example, using a machine failure data, you're predicting that your machine tool might break in 2 hours. Then automatically, you can create a request for a technician to come with a new tool and fix, or you can try to increase the tool life by reducing the speed and increasing the coolant flow. So basically you have a mapping to what needs to be done for a given scenario, predicted. Okay. And the last thing is cognitive use cases. We see very few companies working in this space. We are fortunate to have Bosch work in the space. So cognitive use cases involve cyber physical systems which are completely closed loop, or systems which are capable of taking decisions based on the real time information, in the given scenario, taking the environment in consideration. So best example of cognitive use cases are autonomous driving, where you have a driverless vehicle. The vehicle has to take into account data coming from its video camera, its radars, it is its proximity sensors across the car, and then take a decision how to navigate the traffic, and how to enable automated driving. You see, the business value increases as and when we move from descriptive to cognitive, and the time to deliver the projects also increase. The cognitive projects are a bit complex, so you have to do a lot of data collection, lot of exploration, annotation of data. Might be it is an ensemble of models, right? So the complexity as well increases along with the business value. So if anybody has questions, I'll pause for a second and then I will move to the next slide.
So
Okay.
I have a short query.
Okay.
That, uh, when you say predictive, can we make design of experiments more efficient?
It depends. If you have historical data of many design of experiments, okay,
Yeah.
and if you are able to annotate for a given experiment what was a likely outcome, then with sufficient data you can explore predictive models.
Okay, so the basic challenge what we have faced is to identify the factors which are really going to affect the response, and which factors are to be considered as noise factors.
So
So this,
basically, probably if you have enough data, you should probably try to identify what are the factors. You should try to if you have 100 factors considered, you should try to narrow down those 100 factors to what are those important features that affect the outcome, and try to use techniques like PCA to optimize if you have many features, and try to work that way.
I'll be covering the following in the duration that we have ahead of us. Uh, First, we start with basics. What do we call data? And what is difference between data and a signal? Then we talk a little bit about databases, how data is stored, what is SQL and no SQL database. Then the basic question, what is the purpose of data? Then what are the requirements of Industry 4.0? Since our subject is data analytics for Industry 4.0. So what does Industry 4.0 require? Then what is the scope of data analytics, and types of reports and data visualization provided by data analytics. Uh, then what are the possibilities for industry, Indian industry in this field? And we'll talk, if time on AI/ML, artificial intelligence and machine learning. So that's my day. This is a disclaimer that this subject is being taught primarily with the statistics in mind, and it's a full-fledged MSc level course. So we possibly cannot go in those kind of details. So we'll be restricted to the application side. Okay. But of course, I'll be giving you some terminology, definitions, and what is what, bird's eye overview of the domain. Now, the question, basic question, what is data? Any information that is recorded, shared, or archived for wider and longer term use becomes data. See, many times people ask me that, let us say you have force sensor, a load cell in a machine, or you have a vibration sensor for that meter or a thermometer. It is picking up some reading, or you have a measuring instrument which is having reading. Now that is a reading, that is a signal. But what is the difference between signal and data? When the reading is recorded, shared, and archived for use over long term by multiple people, it is qualified to be called as data. So a signal could be reading of position, temperature, pressure, speed, force coming through a sensor or instrument. It is an information, all right, but it is not data yet. If it stays within the device or controller, and it could be locally used for real-time process control, say closed loop control, PID control, it does not become data. But when it is recorded, archived, and shared across, then it becomes data. So I hope the definition is clear of what we mean by data when we say data analytics. And then there is something called as pooled data, where you can go on recording the data in certain order, like a movie file. You can replay it in the same sequence in which you have stored. That is what is a spooled data. Uh, but there is no flexibility. You cannot do any sequence change. Information content does not evolve, it does not change, it contains the same information. You watch the same movie 10 times, it conveys the same thing. It cannot add information by itself. So that is not data analytics, that is spooled data, okay, which you can record and forget and replay when you want. Processed or analyzed data is something that is transformed to add information content, or it can make it shorter, size, crisp, and relevant for the purpose. So the purpose of data processing and data analysis is to make it usable, palatable, uh, readily referable, and relevant, and above all useful. And database is the structure where data gets stored. So now we come with another term, that what is database. But before that, we have talked about so many things about data analytics in previous presentation. And data analytics as a data science largely concentrates on conventional data. Conventional data meaning salaries, addresses, names, okay, production volumes, numbers, alphanumeric, that's it. Okay. Now there are two types of databases. There is something, a category which is called as SQL compatible database. Now what is this acronym SQL? SQL stands for structured query logic. Okay. And generally this is used to communicate with database, and it is according to ANSI standard. It is the standard language for relational database management system, RDMS. Okay. Relational database management system. Okay. And it is characterized by, you can use SQL when interacting with relational databases where data is stored in tables. So you have to store data in tables like Excel sheet, like MS Access, which have fixed rows and columns. Each of column has a heading which defines what that item is, and all the rows will have the same entry belonging to that particular description. Okay. And those will be, one row is called a record. So there will be several records, one below the other. Now these kind of databases are fixed relational database, where between the columns there is a relationship. And you can have some columns where you have the raw data variable, and some columns can be computed entity. So using the entries already which have come in previous columns, you can do addition, subtraction, multiplication, etc., and have a computed parameter which can come in some other column as a computed entity. So it is called as SQL compatible database, because you are able to filter the data, you are able to write a query, you are able to extract the information by writing a small macro. Okay. So, and that is written in SQL. So SQL statements are used to perform tasks such as update data, retrieve data, modify data, and Some common relational database management systems that use SQL are Oracle, Sybase, Microsoft SQL Server, Access, MS Access, Ingress, etc. So we are somewhat used to it because we have been using it for a couple of decades at least. Sorry. So the standard SQL commands are select, if then else, insert, update, etc. Usual programming kind of things where you can write a small code, okay, and you are able to write a small routine to filter out what you want from the database. Then there can be, of course, various levels of data analytics for manufacturing. One is, of course, at sensor level. At sensor level, you could have some filtering. For example, surface roughness tester has a Gaussian filter. You can filter out some extraneous peaks and valleys, which could be aberration. So you could have sensor level filtering. You have something called as initial data analytics. The term used is IDA. At the sensor itself, you can do some initial data analytics. Okay, but that is not quite the data analytics that we are talking about in this session. That is initial data. It's like post processing basically. You could have a device or machine level control. Then you could have edge control. We talked of this edge. Edge is this here, the bridge. This is called edge. Okay, so edge is the hub that you have. You could have a computer there where you could do edge level data analytics. You could have edge level reporting and some local controls, which could be deployed function wise, process wise, your line wise, or factory level controls. Okay, so that could be there. Or you could have cloud level analytics with authorization control, security, and through reports you do the control. The cloud gives you report, and based on that report you take further action. Cloud, of course, cannot directly control your machinery, so it will give a report somewhere, and based on that report you take further action and integrate it. Then there could be enterprise level controls. There could be beyond enterprise business and market analytics. Complete, let us say, automotive market, you want to have the data analytics, you could do that. And above all, you could have a government level analytics comprising of multiple businesses, multiple sectors and all at economy level. So you could have data analytics coming at various levels really. Okay, the place where it is most successful and where it has come earliest is the stock market. You know, I mean, all these portals show you several reports of how the stocks are faring. Okay, and they do a lot of predictive work, they do a lot of speculative work, they do a lot of trend analysis and things like that. And you can have some automation in the sense that you can have a trigger for buying or selling the shares that you have. You can set the level, it exceeds this level, it will automatically share so many signals which you can already define. Okay, so that kind of automation is also there. So stock market is a place where data analytics and related control has already been realized in a big way. And of course, people like Amazon are using it in a very big way. Facebook, when it starts populating the faces known to you based on your contact list, it is data analytics. Of course, it is popping up the right thing, and you make a phone call to somebody and you find immediately some information about him is flashed on the net when you go to internet. Now, what are the possibilities in a mass production setup for data analytics to play? You can do monitoring and automatic updation of productivity, inventory, all kinds of inventory, finished good inventory, WIP, store inventory. You can plot specific power consumption. That is, since the job is same, power consumed per job, tool cost per job, tool cost per car, specific power consumption per car, waste generated per car. Okay, so that way you can have a better handle on these things. Predictive maintenance, you can always link with all these things. Skill inventory, in terms of operator, how many people you have with what kind of versatility, what kind of capability is available with you, HR capability. So in any eventuality, who should be deployed where? Then machinery spares inventory, you can optimize depending on the spares consumption pattern and commonality of spares, etc., or substituting with Indian is possible. And cost of maintenance you can track machine wise. HR data you can have, you can link it with performance. Based on the actual work which the man has done, you can directly link it with his pay packet or performance review. Nobody has to compile it and present it. You can automatically get it through the system. Overtime control you can have, material logistics you can control. Then for assembly line, there is always a line tending and there is a kitting. Because at assembly line, ideally the assembly operator should not hunt for the parts. The parts should come to him in a tray, preferably in the pattern in which they come on the job, so that mistakes are not there. So in the sequence of production of products, accordingly those trays should reach him. So you can align the kitting with and line tending with the production sequence. This is an important thing which can be possible with all this. Traceability of jobs, obviously. You have a bar chart or whatever job identification of jobs. You can always trace back when it was done, who has done it, and what was the problem, etc. Managing just in time. Yes. Now, artificial intelligence is inspired from human learning, where the learning is based on neurons. There are softwares which are doing neuromatic computing, which are simulating the kind of learning the human brain does. And what human brain does is when a signal comes again, the signals come through these input processes, all these hairs that you see. This is a neuron, and there is a single output. Basically, the concentration of electrolyte when it crosses certain level here, this fires an output, and it goes to various output branches, which is connected in turn to other neurons. Okay, and the more thing a path is used, that ionic channel becomes stronger, becomes a bigger river, and the likelihood of it succeeding into an output that increases. So some synapses, these connections, they aid the firing of neurons, some inhibit it. They drain out the electrolyte actually. So dynamically, depending on success rate, the channels become stronger or weaker, and all these inner interconnections get manipulated. And that is how the data structure changes and correlations change. And that is the way the learning happens in human beings. So this is what we are. We have number of sensory inputs, say smell, taste, sound. So somebody says apple, we see a round red figure and it gives a floral smell. All those sensors are there with us. There is an image from coming from that sensory input, and then there is a correlation. So the learning is that we say that this shape, this color, this taste, this smell is called apple. That is how learning happens. And learning happens at word level always. The child learns apple first, then he learns A for apple, and then he learns Farooq Abdullah and Kashmir from where the apple comes. Okay, so those are the further correlations. So the correlational path, this is the thinking part. This is called deep learning, or this is called data mining. The part over here is data mining, where we are forming sentences out of words, where we are analyzing the word into phonetics or letters, or where we are synthesizing into stories and ideas. Okay. Human sense for organization. The motivation is top line, bottom line, market share, competitive position, financial efficiency, productivity, inventory control, MUDA elimination, quality performance, utilization, responsiveness, compliance, customer satisfaction, risk mitigation, safety, new product introduction faster, market development, brand promotion. But all these are like a complex equation with multiple variables and multiple outputs. So they need AI to solve. With fixed mathematics, you are not able to do justice to this kind of a complex problem. That is the thing. So unless we have that last block of the brain developed through AI and through data analysis, we will be lagging in competency, in competitiveness, performance.